So what happens to humans? Why are we putting it on the ground? Why are we putting it on, why can't we put it somewhere else? Why are we putting it on fields? Why are we transporting it?
Yeah, so since about, I'm going to give away my age, since about 1965, when I was an undergraduate student at San Diego State University, we started investigating sewage outfalls and sewage sludge and wastewater effluents in Southern California to discover why certain marine populations were declining rapidly. And it was easy to determine that the untreated raw sewage that flowed into the Pacific Ocean in San Diego County came from unmanaged wastewater treatment plants. That's the way things were done. A result of our very serious investigations and reporting turned out to be that San Diego and San Diego County ended open dumping through pipes in the Pacific Ocean, and they created wastewater treatment plants. One of the first was on Point Loma, and that was a great improvement. And wildlife came back, fish came back, sea urchins bloomed. Some organisms blossom in the presence of the nutrients in sewage, while others die. And one of the early observations was that when you compromise the populations in marine environments that are sensitive to sewage and industrial wastes by releasing the waters into the oceans and bays, there are other species that are toxin tolerant, and they tend to come in and succeed the natural populations. And in Southern California, that was sea urchins. Sea urchins came in and overrun everything. And then the opposite observation was that when the sewage was diverted from open dumping into La Jolla Cove, for example, in San Diego, all of a sudden natural populations returned. And two of the natural populations also caused havoc, and they were seals and walruses that came in, and they're not walruses. There's two kinds of seals that came in, sea lions and seals, and their populations exploded, and they became breeding grounds for those pinnipeds right there in La Jolla Cove, and their fecal matter alone subsequently decimated the marine life populations. And it's still a problem to this day. So seal and sea lion populations must be controlled for the same reasons. When you get to where we are today in 2022 and how wastewater treatment plants operate and what they intend to do, when raw sewage inflows, meaning from industry, domestic, medical centers, flow into a wastewater treatment plant, the purpose is to create wastewater effluents and precipitated sludges that meet certain standards. The problem is the standards are not related to safety. They're only related to legislatively approved and provided standards that typically do not have any biological or human health or environmental well-being in mind. So, for example, not many years ago, I forget, 10 or 12 years ago, the US EPA did some very serious analytical chemistry investigations of sewage sludge from plants around the US. What they discovered and listed and reported, of which we all have reports, that there were at that time, by their methods, they detected 88,000 toxic chemicals, industrial chemicals, pharmaceuticals, personal care products in anybody's sewage sludge in the US. So even the EPA reported, yes, 88,000 toxic chemicals. Later, the EPA upgraded their report and it was now 137,000 toxic chemicals in anybody's biosolids, which we call toxic sewage sludge, from anybody's wastewater treatment plant. The numbers were revised up again, and the last number I recall now is about 170,000 toxic chemicals in anyone's sewage sludge in the US. Now, if you go sideways and do your own deep dives into the scientific literature, anywhere in the US, North America, the EU, you'll find enough articles. And if you have enough computing power, you can easily see there's well over 400,000 known toxic chemicals, most of them manufactured by industry, that end up in our sewage sludge, whether they're from medical centers, manufacturing plants, homes. It doesn't matter. The number is large, whether it's 170,000 or whether it's 400,000. The bigger the number stops being important, because the core of these chemicals, just as some examples, includes such things as polybrominated diphenyl ether flame retardants. It's a billions of dollar industry in the United States alone generating these chemicals, plus the polychlorinated biphenyls, plus the PFAS chemicals and so on, that are used in industry to treat our clothes, everything we wear, for stain resistance, water resistance, making the colors fast in the garments, making them pliable, making them comfortable, making them resistant to mold, making them resistant to ultraviolet light degradation, making them resistant to oxidation. So those chemicals are known as forever chemicals or persistent chemicals, because they do persist, not only in your clothes, but in the environment. Every time you do your laundry, these chemicals are leached out in the laundry from home, put into the sewage system, goes to the wastewater treatment plant. Sometimes they're converted into other chemicals by microbes or by the treatment process, but in large part, they end up in the wastewater effluents that are released to Puget Sound or our rivers, or sometimes even used for irrigation on our crops. So this is a very big issue. Others kinds of chemicals that you'll find are known as pharmaceutical and personal care products. That's anything from hair dyes to makeup to soaps and lotions and potions, on into the greater sources of toxicity, which are pharmaceutical products. And as just one short example, think about cancer chemotherapeutic agents. People have them administered in hospitals, but they also take them at home or they go to a clinic. These chemicals are designed to kill human cells. It just happens that we try to design cancer chemotherapeutic agents such that they will be somewhat more toxic to rapidly proliferating cancer cells than they are to normal cells. But if you know any cancer patients, and we have many, they lose their hair, they lose their immunity, and typically cancer patients do not die of their cancer. They typically die from infections because their immunity is so suppressed by the administration of cancer chemotherapeutic agents. Now, another key point is that when you design a pharmaceutical, and I am in the biotechnology company business, and I have first-handedly worked on the design of chemotherapeutic and other drugs, anti-infective agents. And when you're administered a drug, whether it's a simple tablet by mouth, the point is that the drug must persist in the human body long enough to do its job. You can't have 100% of the drug processed and assimilated inside of a patient's body such that the amount of drug that is needed for the therapeutic effect is diminished. So drugs are designed so that once the drug's activity has done its job in a human body, for example, more than 50% of the administered drug is then excreted through urine or feces into the wastewater system. And because they're designed to be persistent, they easily survive the microbes and the chemicals in the wastewater treatment plants and system. So they are poured out into our Puget Sound, our groundwaters, our surface waters, onto our crops. And then again, you have another cycle. Whereas food crop plants or animals in agriculture who eat hay, Timothy hay, and other things grown for animal feeds, and corn and wheat, can bioassimilate, take up those same cancer and other pharmaceutical drugs into the human body. And the second term is called bioassimilation, is when you take up the drug, and bioaccumulation is when it concentrates in the human body. So when you go back to the cancer drug idea and you realize that cancer drugs are taken with the aim of killing cancer cells, how do they kill cancer cells? Quite often, they kill cancer cells by causing mutations. Cancer cells form as a result of mutations, and now the purpose of a cancer chemotherapeutic agent is to elicit additional mutations in an effort to kill it. So now you put it out in public. You put it in our water. It's in our drinking water, well water, water that goes through treatment plants. It goes into our animal feedstocks that go to animals that we eat, and it goes into crop plants and plant agriculture for the foodstuffs that we and our animals are intended to eat. So many of these chemicals, whether they're cancer drugs or other kinds of pharmaceuticals, are carried through the food chain into us. The consequences are known. They are studied to a certain degree, but the information that is released to the public generally is watered down. I can't think of a better term, because what is the alternative? Is the alternative to not treat cancer or infections or diabetes or MS? Or do we try to balance the load whereby we can treat people with enough drug to have the desired therapeutic effect without causing additional disease? What I just said globally is a wish, seldom realized in real life. We are victims of our own treatments, and the medical industry works as best as it possibly can, plus some, in order infectious diseases or cancer, while at the same time trying to preserve life and restore us to a meaningful lifespan. So there's a conundrum in there. There's a contradiction in there, where on the one hand, we work as best as we can to treat disease with known adverse effects as part of the package. But then when people send their waste to a wastewater treatment plant, wouldn't it be a good idea if at that point we actually rendered all of those drugs, all of those pharmaceuticals, as being non-biologically active? It's never been done. No one in the wastewater industry has any interest in that whatsoever, because the motivation of the wastewater industry in North America and elsewhere is to find lowest cost and most convenient disposal of our wastes. And why on earth would that, in anyone's right mind, be to put it into our surface and groundwaters and into our food crops? It doesn't make any sense. We're trying to dig out of this hole as a nation. There may be a half a dozen wastewater treatment plants in all of North America that have achieved any success with this objective. And we're talking about somewhere in the neighborhood of 17,000 wastewater treatment plants in North America. And from my perspective, almost none of them actually work. other than provide lowest cost, most convenient methods of disposal. But there are two main products that come out of a wastewater treatment plant. One is the fluid. It comes out as wastewater effluents that are returned to our surface and groundwaters with barely any treatment. And the other is toxic sewage sludge. So what do? We put it in our forests, we put it on our farms. Some of it goes to composting. None of it is ever evaluated for full, comprehensive, qualitative chemical analysis. And what that means is that we know there are at least 400,000 toxic chemicals in anybody's sewage sludge, but we don't know what the rest are or what they do. We haven't taken the time and expense to do the rest of the qualitative, comprehensive chemical analysis. It's in process around the world, but it hasn't been done. So when someone tells you, such as King County loves their 2-word statement, it's safe, it's actually a violation of the law. Because when an engineer from King County's Solid Waste Division told me that again recently for the 100th time, I immediately called up someone at the U.S. Environmental Protection Agency who works in toxics. And I said, King County engineer just told a crowd of 250 near the Cedar Hills Regional Landfill that sewage sludge from a wastewater treatment plant is safe. And the EPA person just went out of control. No one can claim it's safe until it has been subjected to safety toxicology studies by and at an EPA certified toxicology testing laboratory. And beyond just the definition and detection and elucidation of the chemicals themselves, they must do toxicology testing studies under current good laboratory practices, also at an EPA certified lab. So King County and the state of Washington have no right and no license to tell the public that such things are safe, whether it's wastewater effluents or whether it's toxic sewage sludge. It's against the law.